Welcome, dear friend, to Luminous Uplift, a gentle sanctuary where science becomes a lullaby and the wonders of the universe are whispered softly into the quiet of your evening. We are so glad you are here. Perhaps today was long. Perhaps it carried more weight than you expected. Whatever the hours brought you, you can set it all down now. Let your shoulders soften, let your breath slow, and allow this moment to belong entirely to you. You have found your way here, and that is enough. Here at Luminous Uplift, we believe that wonder and serenity are not opposites. They are companions. Together, they carry us somewhere extraordinary. Tonight, we invite you to drift upward, far beyond the familiar world, into the breathtaking sweep of our own cosmic home, the Milky Way galaxy. Imagine floating gently through rivers of ancient starlight, drifting past clouds of shimmering cosmic dust, and gliding silently through spiraling arms that stretch across 100,000 light-years of quiet, radiant space. This is a place of peaceful exploration, where every fact becomes a soft revelation and every discovery feels less like a lesson and more like a dream unfolding. If these journeys bring you comfort, we warmly invite you to like this video and subscribe so we may continue meeting you here in the stillness. Now, let us begin our journey into the heart of the Milky Way. There is something that happens to the human mind when it meets the night sky for the very first time, truly meets it, without the interference of streetlights or the orange glow of cities bleeding upward into the dark. Something ancient stirs, something that has been sleeping inside the chest, quiet and patient, suddenly opens its eyes. It is a recognition deep and wordless, like hearing a song you have never learned but somehow already know. This feeling, this particular trembling wonder, is not new to you. It is not new to anyone. It has been felt by every human being who has ever drawn breath beneath an open sky. Every child who ever wandered outside on a summer night and stopped, suddenly mouth falling open, neck craning back, heart going very still. It is, perhaps, the oldest feeling in the world. Close your eyes for a moment if you like. Let your body settle into wherever you are resting right now. Feel the weight of yourself, the gentle pressure of the surface beneath you, the slow and easy rhythm of your breathing. There is nowhere you need to be. There is nothing you need to do. You are simply here, drifting gently at the edge of sleep, and I'm going to take you somewhere very beautiful, somewhere very old, and very, very quiet. Let us begin at the beginning, or at least as close to the beginning as we can reach. Let us begin with a band of light. Imagine a night with no moon, a night in a place far from any city, far from any road, far from any window glowing yellow in the dark. A meadow, perhaps, or a hillside, or a wide and open plain stretching away in every direction until the land and the sky become the same soft thing. The air is cool and carries the faint green smell of grass and earth. The insects are singing their small, continuous songs. And above you, above everything, the sky has opened itself completely. A great dome of darkness, so total and so clear that the stars do not merely appear as pinpricks of light, but as a living, breathing presence. A field of fire spread across the infinite ceiling of the world. And there, cutting across that darkness from one horizon to the other, there is something that is not quite darkness and not quite light. A band, a river, a smear of pale luminescence so soft and diffuse that it seems less like something you're seeing and more like something you're imagining, like the memory of light rather than light itself. It stretches across the entire sky, arching overhead, wider in some places, narrower in others, with patches and lanes of deeper darkness threading through it like rivers within a river. It is faintly, gently, impossibly beautiful, and it is entirely real. This is the Milky Way as it appears to the naked eye, to your eye, to my eye, to the eyes of every human being who has ever stood in true darkness and looked up. A faint band of light, continuous and ancient, stretching from one end of the visible sky to the other. You do not need a telescope to see it. You do not need any instrument at all. You need only darkness and patience and a willingness to let your eyes relax and open fully, to stop straining and simply receive what the sky is offering. Under the right conditions, which is to say under a genuinely dark sky on a clear night, the Milky Way is visible to any human being with ordinary eyesight. It has always been visible. It was visible 10,000 years ago, and 100,000 years ago, and long before any human language existed to give it a name. And so, naturally, inevitably, human beings gave it names. They gave it stories. They gave it everything they had, which is what human beings do when they encounter something too large and too mysterious to simply leave alone. They reach toward it with their imaginations, which is the most human reaching of all. The ancient Greeks, those careful and passionate observers of the natural world, looked up at this pale river arching over their islands and their temples and their olive groves, and they called it Galaxius Kyklos. Say those words slowly. Let them dissolve on your tongue like something sweet. Galaxius Kyklos, the Milky Circle. They believed, in one of the most beautiful and enduring of their many beautiful myths, that this band of light was milk. Specifically, it was the milk of the goddess Hera, queen of the gods, wife of Zeus, spilled across the heavens in a moment of celestial accident or celestial generosity, depending on which version of the story was being told that evening around the fire. In some tellings, the infant Heracles, that great and complicated hero, was placed at Hera's breast while she slept, so that he might drink divine milk and gain immortality. When she woke and pulled him away, her milk sprayed across the sky, becoming the luminous trail that Greeks and their descendants would observe and wonder at for centuries to come. It is a story of nourishment and accident and cosmic consequence, of something spilled becoming something permanent and grand. There is a particular kind of poetry in imagining the universe decorated by a goddess's milk, in imagining that the light above us is a remnant of nurturing, of feeding, of life, sustaining life. From the Greeks, the story passed into Latin, into the language of Rome, and the phrase settled into something slightly different, something that has come down through the long corridor of centuries and arrived intact to our own lips. Via Lactea, the Milky Way, the road of milk, the path of milk stretching through the heavens. It is from this Latin name, Via Lactea, that our own English words come, our own casual, everyday phrase for this extraordinary thing, the Milky Way. We say it so easily, so familiarly, the way you might say the name of a street you have walked down 1,000 times, not pausing to consider that the name is ancient and that the thing it names is ancient beyond any easy comprehension. But the Greeks and Romans were far from the first. They were not even close to the first. They were, In the long and patient story of human attention turned upward toward that band of light, relatively recent arrivals. Because human beings have been telling stories about the Milky Way for at least 17,000 years, possibly longer. There are cave paintings, those astonishing relics of the earliest chapters of human consciousness, deep inside the earth, in places like Lascaux in France, and other ancient sites scattered across the world. And some researchers believe that certain arrangements of marks and images on those ancient walls may represent the night sky, may represent the band of light that our distant ancestors saw overhead 17,000 years ago. Let that settle into you gently. 17,000 years. The things that have come and gone in that span of time. The civilizations risen and fallen. The languages born and forgotten. The generations of human lives lived completely from first breath to last. And through all of it, through every one of those thousands of years, human beings looked up on clear dark nights and saw the same pale river of light arching above them, saw it and felt something, were moved by it, were compelled to mark it, to remember it, to reach toward it with whatever tools of meaning they possessed. This continuity is worth dwelling on, worth letting yourself feel quietly. When you look at the Milky Way, and I hope that one day soon, you will have the chance to do so in genuine darkness. You are doing something that connects you in an unbroken chain to every human being who has ever lived. The nomadic hunters moving across Ice Age landscapes. The first farmers watching the seasonal sky for signals about when to plant. The priests and navigators and poets and shepherds and children of every civilization that has ever flowered on this earth. They all looked up. They all saw this. And now you're looking up too, at least in your imagination. In this quiet space between waking and sleeping, where the most real things often live. And yet, and this is something both sad and strange to hold, much of humanity has lost access to this experience. The spread of artificial light across the surface of the earth, that slow and relentless brightening that has transformed the human night over the past century or so, has created what we call light pollution. A diffuse glow that fills the lower atmosphere and washes out the fainter lights of the universe. The stars nearest and brightest still penetrate this glow well enough to be seen. The moon, of course, sails above it. But the Milky Way, which is not a point of light, but a diffuse and delicate band, requires genuinely dark skies to be visible. It cannot compete with the reflected light of millions of street lamps and illuminated windows and glowing screens and the thousand other sources of brightness that fill our modern nights. And so, astonishingly, heartbreakingly, nearly 1/3 of all human beings alive on Earth today cannot see the Milky Way with their naked eyes, cannot see it from where they live. The sky above their homes, above their cities and suburbs and towns, is simply too bright. The ancient river of light, the one their ancestors named and worshipped and wove into their deepest stories, is invisible to them, hidden not by clouds, not by storms, but by the light of their own civilization. There is something in this worth sitting with, not in an anxious or troubled way, because this is not that kind of story. This is a gentle story, a sleep story, a story for the soft edges of consciousness, but simply worth acknowledging, worth noticing, worth feeling the quiet strangeness of. We have come so far, we human beings, and built so much and illuminated so many of our dark places, and in doing so we have dimmed one of the oldest and most universally shared experiences our species has ever known. We have brightened the earth, and in doing so we have darkened our view of the cosmos. It is not a tragedy. Exactly. It is simply a consequence, an unintended cost of all that illumination, and it is one that more and more people are beginning to notice and to want to gently, carefully address. There are dark sky preserves now, protected places where the light pollution is kept at bay, where the ancient view is preserved, where you can still go and see the sky as it appeared 10,000 years ago. These places exist because enough people felt the loss, felt the absence of that particular wonder, and decided that it was worth protecting. But tonight, in this soft and drowsy place where we have gathered together, there is no light pollution. Tonight, in the landscape of the imagination, the sky is perfectly, profoundly dark. The stars are extravagant overhead, more than you can count, more than you can take in, a riot of quiet fire. And the Milky Way is there, as it has always been there, as it was there for the cave painters and the Greek philosophers and the Roman poets, and every human soul who has ever lain on their back on the ground and looked straight up into the immensity of the universe and felt simultaneously very small and somehow mysteriously very much at home. Feel your body relaxing now. Feel the weight of your eyelids, the gentle slowing of your thoughts. Let the images come softly, without forcing, without gripping. A dark meadow, a warm night just cool enough for comfort, the smell of grass and the singing of insects, and overhead the extraordinary, ordinary, ancient miracle of the night sky doing what it has always done, simply shining, simply being there. And as your eyes grow soft and heavy, imagine lying in a field of cool grass 10,000 years ago, looking up at a sky so dark and deep that the great river of stars above you seemed close enough to touch, close enough to reach out and draw your fingers through like water through a quiet stream. That ancient person lying in the grass 10,000 years ago had no words for what they were seeing, no mathematics, no telescopes, no libraries full of careful thought. And yet they felt it, the way you might feel the presence of something enormous standing just behind you in a dark room, not frightening, but immense, breathing slowly, older than anything you could name. They felt that the river of light above them was not simply scattered, not random, not the careless throwing of diamonds across velvet, but that it had a shape, a direction, a structure as deliberate and as beautiful as anything built by patient and loving hands. And now, softly, we know what that shape is. Let your breathing slow for a moment. Let the weight of your body settle into whatever holds you. Picture yourself not lying in a field now, but floating, impossibly high, far above the flat disk of everything you have ever known, rising through the clouds and then through the thin, cold membrane where the air gives way to space, rising still, past the moon hanging silver and patient, past the planets that orbit in their long ellipses, past the outermost whisper of our solar system, and then further, much further, until the sun itself becomes just one pale point of light among countless others, until even that disappears into the vast and luminous architecture spread below you, like a city seen from an airplane at night. Only this city is 100,000 light years wide. Only this city has been burning for 10 billion years. What you would see hovering there in the impossible silence is a spiral, not a perfect circle, not a cloud or a smear, but a true spiral, elegant and unhurried, turning so slowly that a single rotation takes more than 200 million years. It would remind you perhaps of something you have seen before, a hurricane photographed from space, or the way cream slowly unfolds in a cup of coffee, or the pattern inside a nautilus shell that you once held up to the light and thought beautiful without quite knowing why. The Milky Way is all of these things at once. It is a living architecture of gas and dust and stars and dark matter and time, winding through itself in graceful arms that trail like the sleeves of something ancient and slow-moving. But here is what makes our galaxy particular, what gives it its own specific character among the billions of galaxies scattered through the observable universe. At its very center, there is not simply a point, not simply a dense cluster of stars gathering inward, but a bar. A long, bright, elongated bar of stars stretching across the middle of the galaxy, like the crosspiece of a great cathedral window, like the beam of a balance held level between two hands. Scientists call this a barred spiral galaxy, and when they say that word barred, try to hold the image of it, something ancient and structural, something load-bearing in the architecture of the cosmos, a lintel across a doorway into darkness and light. From the two far ends of this central bar, the spiral arms unspool like the threads of something being slowly woven. 4 great arms, each one a river of stars and nebulae, and young blue suns and cold dark clouds where new stars are even now being born, curving away from the bar in long, graceful arcs that give the whole structure its famous spiral shape. These arms have names, patient names given by the scientists who spent their lives learning to read the galaxy the way you might learn to read an old and difficult text in a language that was not your mother tongue. There is the Perseus arm, glittering and distant toward the outer edges. There is the Sagittarius arm, bright with young stars and streaming with dust. There is the Centaurus arm curving around the other side of the galaxy, and the Norma arm winding behind and below, each one a different chapter in the same long story. Each one thick with the material of worlds. And where are we in all of this? Where does our small sun rest within this grand architecture? Not at the center, not at the dramatic heart of things, not on one of the 4 great arms which carry so much of the galaxy's mass and brightness and history. We live on something smaller and quieter, a minor feature, a gentle spur that branches off between 2 of the major arms like a side road off a great highway, a room in a wing in a cathedral. Scientists call it the Orion arm, named after the constellation that rises and sets above our heads each winter, though of course those stars of Orion are our neighbors in this same quiet spur, part of our small local neighborhood in the galaxy's great body. We sit here, in this minor arm, this gentle offshoot, roughly 26,000 light-years from the center, from the bar, from the enormous dark heart of the galaxy, where a black hole 4 million times the mass of our sun rests in patient silence. 26,000 light-years. Hold that number like a stone in your palm. Feel its weight. Light moves at the fastest speed anything in our universe can travel, crossing the distance from the Earth to the Moon in barely more than a second, circling our entire planet 7 times in a single heartbeat. And yet even light, traveling at that impossible speed without rest, without slowing, without stopping for breath or direction, would take 26,000 years to cross the distance between our sun and the center of our own galaxy. If light had left our sun at the moment when our ancestors were first learning to grind grain, when the ice sheet still lay heavy across the north and the rivers ran with snowmelt, that light would only now be arriving at the galactic center. We are, in the geography of the Milky Way, somewhere quiet, somewhere in the middle distance, somewhere neither here nor there, which is perhaps the most human place to be. For a very long time, we did not know that we lived in a barred spiral galaxy. We suspected spirals, yes. We could see from studying other galaxies that spirals were common, that the universe seemed to have a fondness for that particular shape, that gentle inward winding. But the bar, that central crosspiece of stars, that structural element at the heart of everything, was hidden from us for a very long time. And the reason it was hidden is one of those beautiful small ironies that science offers to those who look carefully at the world. It was hidden because we live inside it. We are embedded within the disk of the Milky Way, our view of the galaxy's own structure obscured by the very stars and dust we are trying to see past. Like someone trying to draw a map of their own house while standing inside one of the rooms without any windows. You can feel the walls, you can pace the floor, but the overall shape, the plan, the blueprint, remains invisible to you from the inside. It was not until the early years of this century, the early 2000s, when astronomers turned their infrared telescopes toward the center of the galaxy. Instruments that can peer through the dust clouds that block ordinary visible light, the way fog blocks a headlamp, that they found the bar at last. The stars there did not cluster in a sphere as they had once thought. They stretched, they elongated, they spread themselves out in the unmistakable shape of something deliberate and constructed. A bar of stars tens of thousands of light years long, anchoring the whole spiral like the spine of something vast and patient. It was one of those moments in science that feels less like discovery and more like recognition, like finding in a drawer you have opened 1,000 times. A photograph you did not know had been taken of you, and recognizing your own face. Think for a moment about the strangeness and the beauty of that. For all of human history, for all the centuries of watching and wondering and mapping the night sky, from the Babylonians to Galileo, to Hubble, to the engineers of the modern infrared observatories, we have been living inside a barred spiral galaxy and not knowing it, the way you might live your whole life in a cathedral and never see it from the air, never see the cruciform shape of it, never see how the nave and the transepts cross at the center where the great dome rises. The shape of our home was not visible to us until we learned to look in a different kind of light. And there is something deeply comforting in that. If you let yourself feel it while your breathing slows and the world grows soft around you, there are things that take a very long time to see. There are shapes that only reveal themselves when you find the right way of looking, the right instrument, the right quality of attention. The galaxy did not hide itself from us out of cruelty or indifference. It was simply very large, and we were very small, and inside it, and young in the ways of seeing. But we learned slowly, carefully, with patience that accumulated across generations. We learned. The disk of the Milky Way, that flat, swirling plane where the spiral arms and the bar and the spur where we live all reside, is 100,000 light years across. That number has been mentioned. That great diameter of 100,000 years of light travel. But what is perhaps more quietly astonishing is how thin it is. That enormous diameter, that sweep of 100,000 light years, sits within a disk that in most places is only about 1,000 light years thick. Imagine a coin, a single wide flat coin, and then imagine that coin scaled up to the size of a dining table. The thickness of that coin relative to its width is something like the thickness of the Milky Way's disk relative to its diameter. We live in something not spherical and grand like a soap bubble, but flat, profoundly flat, a lens of stars floating in the larger darkness of the halo that surrounds it. That flatness is part of the architecture too. Part of the cathedral seen from above. Because when you look at the Milky Way's spiral arms, you're looking at features that exist within this remarkably thin plane. Structures of enormous lateral reach, but almost delicate vertical depth. Like an enormous mural painted on a surface of barely any thickness at all. The gas and the dust and the young stars are all pressed toward this thin plane by the slow gravity of rotation, flattened over billions of years into something like a page. A vast illuminated page covered in the writing of suns. And all of this, every arm and bar and spur, every ancient red giant and newly kindled blue star, every cold dark cloud and bright nebula, every planet circling every sun, every grain of dust drifting in the interstellar medium, all of it is part of the same rotating, breathing, slowly evolving body. All of it is the Milky Way, your galaxy, the one that contains your sky, your night, your field of cool grass, your memories, your dreams. You have always lived inside a barred spiral galaxy. You have always been 26,000 light years from a sleeping giant at the center. You have always been riding one of the minor spurs of one of the four great arms, carried around the galactic center at an enormous speed that you have never once felt. A speed of about 500,000 miles per hour relative to the galactic center, and yet so smooth, so vast, so undramatic in the moment-to-moment of a human life that you have never felt it, not once. Not even in the deepest stillness of a night like this one. Let the thought of it open outward inside you like a slow breath. You're not still. You have never been still. Even lying there, eyes closed, breathing gently, held by the warm, dark gravity of your own small world, you are moving through the arm of a spiral galaxy, turning around a center you cannot see, carried within a disk of stars 100,000 light years wide and barely 1,000 thick, accompanied by 400 billion other suns, each with their own stories, their own planetary children, their own chances at whatever light and warmth and time can make possible. And this great spiral, this slowly turning pinwheel of light, drifts through the cosmos in a shape so grand that even the light crossing from one edge to the other would take 100,000 years. And at its very heart there rests this great spiral, this slowly turning pinwheel of light, drifts through the cosmos in a shape so grand that even the light crossing from one edge to the other would take 100,000 years, and at its very heart there rests something extraordinary. Something that no human eye had ever truly seen until just a few years ago. Something that had been suspected, theorized, imagined in the quiet language of mathematics for generations before we finally, gently turned our instruments toward it and held our breath and looked. At the center of our galaxy, tucked within the dense and glittering core where stars are packed so closely that the sky, if you could stand on a world there, would blaze with light, even at what we might call night. There sits a presence, a gravitational enormity, a silence given mass. We call it Sagittarius A star, and the name itself carries something of the poetry of the place, named for the constellation of the Archer through which this galactic center appears to us from our vantage point in one of the quiet outer arms. That word star appended, not because it burns with light in the way we usually mean, but because in the notation of astronomers, it carries a small asterisk, a mark that signifies something special, something annotated, something that demands a footnote in the great ledger of the universe. And special it is, in ways that are difficult to hold in the mind all at once, the way you might struggle to hold a vast and ancient thing in the cup of your two hands. Sagittarius A star has a mass approximately 4 million times that of our own sun. Let that settle for a moment, the way a stone settles through still water, slowly finding its depth. Our sun, that enormous burning sphere of hydrogen and helium around which all the familiar planets of our small solar system turn, is itself so large that more than 1 million Earths could fit within it. And yet Sagittarius A star contains the equivalent mass of 4 million such suns, compressed into a region of space not much larger than the distance between our sun and the orbit of Mercury. Not 4 million stars spread across some great distance, not 4 million suns arranged in a cluster that you might see from afar, but 4 million solar masses concentrated into a point, or something so close to a point that the distinction barely matters to the human imagination. This is what we mean when we say supermassive. This is what the word is reaching for when ordinary language finds itself a little short of breath. A black hole forms when mass collapses inward beyond a certain threshold, when gravity wins so completely that nothing, not matter, not light, not even the idea of escape, can pull free of its grip. Surrounding that central singularity, that place where our equations begin to soften and blur with the effort of describing something so extreme, there is a boundary, a surface of no return that we call the event horizon. It is not a physical wall. You would not see it gleaming if you approached it. You would not feel it under your hands, but cross it, and you would never come back. Because to come back, you would need to travel faster than light, and light itself, that ancient traveler, cannot manage such a thing. The event horizon of Sagittarius A star stretches roughly 12 million miles across. 12 million miles of invisible threshold. 12 million miles of the universe's most serious boundary, floating at the very center of everything we call home. For decades, astronomers knew it was there. They could feel its presence in the data, the way you can feel the weight of something heavy in a room, even before your eyes fully adjust to the dark. They watched the stars in the galactic center move, and the movement told them everything. Stars very close to Sagittarius A star orbited at speeds that seem almost impossible by the standards of our ordinary experience. One of these stars, known to astronomers simply as S2, a designation as quiet and unassuming as a library catalog number, completes an entire orbit around the black hole once every 16 years. 16 years. Our own Earth takes 1 year to circle the sun, and we speak of that as a natural rhythm, a heartbeat of seasons, a turning of the world. But S2, swinging around an object 4 million times more massive, traces its path in just 16 years. And in doing so, it moves at something like 3% of the speed of light at its closest approach. 3% of the speed of light. That is approximately 17,000 miles per second at its swiftest, a speed so vast that if S2 were passing through our own solar system at that pace, it would cross the entire diameter of Earth's orbit in a matter of hours. And yet it orbits, and yet it traces its great ellipse and returns, faithfully in just 16 years, as though it were caught in some slow and elegant dance with something it cannot see and cannot leave. We watched S2 and the other stars near the galactic center for years, for decades. We tracked their paths with careful instruments, and from the curves they traced, We could calculate the mass of the thing they orbited. This is gravity as language. Gravity is a kind of speaking, the stars telling us through the shapes of their paths what lies at the center of their world. And what they told us was that the mass was real, was enormous, was concentrated in a space far too small for any ordinary collection of stars or gas to occupy. The conclusion was unavoidable as sleep at the end of a long and tired day. At the center of our galaxy, there is a supermassive black hole. It is not a metaphor. It is not a theoretical placeholder. It is a thing, a real and gravitationally present thing. And it has been there for billions of years, shaping the galaxy around it the way a stone in a stream shapes the water that flows past. But for all our certainty, all our calculations and inferences, we had never actually seen it. Not directly, not as an image, a picture, a shape in the sky. We knew it the way you might know the face of someone from everything others have told you, from the impression they leave on the room, from the way people turn when they enter. We had never looked directly upon it. Then, in 2022, something remarkable happened. The Event Horizon Telescope collaboration, a team of scientists who had linked radio telescopes from across the entire surface of the Earth into a single planet-sized instrument, released the first direct image of Sagittarius A star. It appeared as a ring of glowing light, a halo of hot gas and energized material caught at the very edge of the event horizon, curving around the black hole under the immense distortion of its gravity. Light itself bending as it tried to pass nearby, some of it curling all the way around to reach our instruments from directions we might not have expected. And at the center of that glowing ring, a darkness, a void, a shadow cast not by any solid object, but by the absence of light, by the fact that nothing from inside the event horizon could reach us. There is something deeply affecting about that image, something that quiets the room when you look at it. Here's the thing we knew was there. The thing the stars had been telling us about with their graceful orbits, and it looks exactly as the mathematics said it should look. A bright ring around an absolute dark, a halo of fire around a silence, and you realize that the universe, even in its most extreme expressions, is consistent. It keeps its promises. The equations held, and what they promised was there, patient and enormous and unsurprised by our arrival. What Sagittarius A star does now, in this era, in this chapter of the galaxy's long life, is perhaps more surprising than its immensity. For all its mass, for all the gravitational authority it holds over the stars and clouds of gas in the galactic center, Sagittarius A star is currently relatively quiet. It is not actively consuming large amounts of material. It is not roaring with the fierce light of a quasar, not blasting jets of energized plasma into the space above and below the galactic plane, not feeding in the frenzied way that some black holes in other galaxies feed. It sits at the center of everything in a state of deep and watchful stillness. Occasionally, there are small flares, brief, brightening events when a cloud of gas or some smaller object drifts close enough to be disturbed by the tidal forces near the event horizon. And for a short time, Sagittarius A star glimmers a little in the X-ray part of the spectrum. But these are quiet murmurs compared to what it might do, compared to what black holes of similar mass in other galaxies are doing as they devour surrounding material with a voracious and brilliant hunger. Sagittarius A star, at least for now, rests. There is something almost reassuring in this. the most massive object in our galactic neighborhood. The gravitational sovereign of 400 billion stars presides over its domain in a state of relative tranquility. The center of our galaxy is not a place of current catastrophe. It is not tearing itself apart. The spiral arms extend from the central regions and sweep outward in their long, slow curves, and the stars within them go about their business of burning and fusing and living out their stellar lives. And at the center of it all, the black hole waits quietly, having eaten most of what was available in its immediate vicinity long ago, having shaped and settled and arranged things over billions of years into the configuration we now call home. It is strange, perhaps, to feel a kind of peace when thinking about a supermassive black hole, about an object so extreme that time itself behaves differently near its surface, that space curves sharply inward toward a singularity we cannot fully describe, that the very laws of physics as we understand them reach a kind of horizon within the event horizon, a place where our current descriptions give way to something we have not yet fully worked out. And yet there is a peace there in the contemplating of it, in the knowledge that this enormous thing has been present at the heart of our galaxy for billions of years, older than Earth, older than our sun, perhaps nearly as old as the galaxy itself, and has held everything together with its gravity, anchoring the galactic center, influencing the great structure of the arms and the overall rotation of this enormous island of stars. It is like discovering that the quiet center of a long familiar home is actually held together by something ancient and immovable, something you never had occasion to notice because it was simply always there, doing its work without calling attention to itself. The stars near Sagittarius A star continue their orbits. S2 and its neighbors, designated with the simple letter S and a number, S1, S2, S38, S55, trace their ellipses in the dense and blazing environment of the galactic center, completing paths that take years or decades, moving at extraordinary speeds, subject to gravitational forces we on our quiet outer arm of the galaxy will never feel directly. Each orbit they complete is a kind of sentence written in the language of gravity, a sentence that says, here is mass, here is curvature, here is the shaping force around which we turn. Scientists watch these stars with great care because their orbits are one of the finest natural laboratories in the observable universe for testing the predictions of general relativity, for asking the deepest questions about how gravity behaves in extreme conditions, for listening to what the universe is willing to tell us about its own most fundamental rules. And so we float here, out on one of the quieter arms of the spiral, far from the crowded and starlit center, far from the flicker of those fast-moving stars, separated from Sagittarius A star by approximately 26,000 light-years, which is to say that the light reaching us now from that central region set out on its journey around the time that our ancient human ancestors were painting images on cave walls, were crossing land bridges between continents, were beginning to gather in the earliest settlements that would one day become what we call civilization. The center of our galaxy is not close, and yet it is ours. It is the gravitational heart of the structure we inhabit, the axle around which the entire wheel of the Milky Way turns slowly, over periods of time that make ordinary human measures feel like the briefest of sighs. To know that this is at the center of our home galaxy is to feel something shift gently inside the chest. Not fear exactly, but something adjacent to awe. Something that is awe made quiet and contemplative by the lateness of the hour, by the darkness outside the window, by the soft weight of the night, pressing gently on everything. The universe contains these things, these enormous and patient silences at the centers of galaxies, and we are part of the galaxy that contains this one, and that feels, somehow, like a kind of belonging, like knowing the deep grammar of the place you come from, even if you will never travel there, even if the center of your own galaxy is as remote and unreachable as any dream. There is something in the very stillness of Sagittarius A star that mirrors the stillness of this hour, the way the late night settles around you, the way everything grows quiet, and the world beyond the immediate seems to recede. The black hole does not rush. It does not strain or seek. It simply is, at the center of everything, holding the galaxy together with the patient authority of something that has had billions of years to grow comfortable in its place. And the galaxy turns around it, the way the night turns, slowly, carrying its cargo of stars and clouds and ancient light through the dark. A darkness so profound and yet so perfectly still that the stars nearest to it dance in great sweeping arcs, tracing invisible circles around a silence at the center of everything. And from that center, vast rivers of ancient starlight flow outward along the spiral arms, carrying with them the dust and memory of a darkness so profound and yet so perfectly still that the stars nearest to it dance in great sweeping arcs, tracing invisible circles around a silence at the center of everything. And from that center, vast rivers of ancient starlight flow outward along the spiral arms, carrying with them the dust and memory of every star that has ever lived and breathed, and burned within this great wheeling city of light we call home. And there are so many of them, so very wonderfully many. When astronomers turn their instruments toward the Milky Way and begin to count, to estimate, to feel their way through the numbers the way you might feel your way through a darkened room with your hands outstretched, they arrive at figures that the waking mind can barely hold. Somewhere between 100 billion and 400 billion stars drift within the boundaries of our galaxy. 100 billion at the least, perhaps 400 billion in truth. The uncertainty itself is part of the beauty, because it means that even now, even with all our instruments and mathematics, the Milky Way contains more wonder than we have yet fully named. There is always more. There is always another light we have not yet counted, another fire we have not yet found. Try, gently, not to grasp the number all at once. Instead, let it settle over you the way a blanket settles, softly covering everything. 100 billion candles in the dark, and each one burning, each one a sun to something, or at least a sun to the possibility of something. Each one ancient beyond the reach of ordinary imagination, and yet each one perfectly, quietly present in the slow dream of galactic time. If you were to count those stars, one each second, without stopping, without sleeping, it would take you more than 3,000 years to count even a single billion of them. 3,000 years for 1 billion, and there are at least 100 of those billions nestled into the arms of our galaxy alone. The numbers dissolve into something more like poetry than arithmetic, and perhaps that is exactly as it should be. Perhaps some truths are better felt than calculated, better received than understood. And so let us not count them, but instead, let us meet them. Let us wander among them the way you wander through a memory, slowly, without urgency, touching each one lightly before moving on. The most common stars, by far, are ones you would never see with your bare eyes on even the clearest night. They are the red dwarfs, small and ancient and extraordinarily patient. Of every 10 stars in the Milky Way, roughly 7 of them are red dwarfs. 7 out of 10. They are the quiet majority, the ones who do not announce themselves, who burn at such gentle temperatures that their light leans toward the deep, warm end of the spectrum, a color closer to ember than to flame. They are not dramatic. They do not flare or swell or collapse in spectacular violence. They simply burn steadily and slowly for lengths of time that make the current age of the universe seem brief by comparison. A red dwarf star might continue its slow, measured fusion for 10 trillion years. 10 trillion. Our universe is currently less than 14 billion years old, which means that not a single red dwarf star that has ever formed has yet had time to die of natural causes. They are all still burning, every last one of them, every red dwarf that ignited in the earliest ages of the galaxy, still quietly tending its small flame in the dark. There is something deeply reassuring in this, something that feels almost like a lullaby written in the language of physics. These are the patient ones, the enduring ones, the stars that do not hurry. When you look at the sky on a summer night, the stars that catch your eye, the ones that gleam with cool blue-white brightness or steady golden warmth, are not the common ones. They are the rare ones. They are the stars dramatic enough to shine across vast distances and still demand your attention. But between them, invisible to your eye, the red dwarfs glow on in their quiet billions, saying nothing, going nowhere, lasting longer than thought can comfortably follow. Then, there are those who live at the other end of the spectrum entirely. The ones who burn so fiercely that their very intensity ensures they cannot last. The massive blue giants are among the most luminous objects in the galaxy, shining with a brilliance hundreds of thousands of times greater than our sun. They are impossibly beautiful and impossibly brief. Where a red dwarf might endure for trillions of years, a blue giant exhausts its fuel in mere millions, which in the timescale of the cosmos is something barely longer than a held breath. A flash of light so quick, the galaxy has scarcely registered it before the star is already gone. But gone is not the right word. Not quite, because when a massive star dies, it does not simply stop. It ends in an act of extraordinary generosity. The final collapse of a massive star, the supernova, releases more energy in seconds than our sun will produce across its entire 10 billion year life. The outer layers of the star are flung outward into space with tremendous force, and carried within them, seeded into the expanding cloud of gas and dust and light, are the heavy elements that the star spent its entire life creating in the slow nuclear alchemy of its core. Carbon, oxygen, nitrogen, iron, silicon. All the materials that the universe began without, all the complexity that simple hydrogen and helium could not provide on their own, these things were made inside stars and scattered by their deaths. The supernova is not an ending. It is a broadcast. It is a star sending everything it ever made out into the galaxy, gifting it to the gas clouds that will someday collapse into new stars, new planets, new oceans, new creatures who will one day look up and wonder where they came from. And you can feel this truth somewhere deeper than thought, somewhere in the quiet body that breathes and rests beneath the weight of blankets. Because you are one of those creatures, you are made of that gift. But let us not rush ahead. Let us stay a little longer in the warmth of the stellar population, drifting through the variety of it all the way one drifts through a museum after closing time, alone with the exhibits, unhurried. Our own sun sits near the middle of the stellar spectrum, neither the smallest nor the largest, neither the dimmest nor the most brilliant. It is what astronomers call a yellow dwarf, though its light, if seen unfiltered by atmosphere, would appear closer to white than yellow. It is a G-type star, and among the family of stars, it occupies a comfortable middle-aged place, not particularly remarkable in size or brightness, not especially notable in its age, which currently rests somewhere around 4.5 billion years, with another 5 billion or so still remaining ahead of it. It is, by any cosmic measure, an ordinary star. And yet from its ordinariness comes everything. From its unremarkable steadiness comes the warmth that falls on your closed eyelids on a spring afternoon, the light that stirs the ocean into weather, the energy that flows up through the roots of trees and becomes leaves, becomes fruit, becomes the food that becomes, in time, the thought behind these very words, the breath that carries them, the ears that receive them. Ordinariness, it turns out, is not a small thing. Ordinariness, done consistently across billions of years, is the very foundation of everything you have ever known. There is something in this worth holding gently as you rest. The extraordinary universe made itself from ordinary pieces. It chose patience over spectacle. It built everything worth building with time and repetition and quiet constancy. You might recognize something of yourself in this. The things you have built slowly, the things you have tended over years, the ordinary faithfulness of showing up, of breathing, of continuing to exist and love and try. These are not small things either. They have the same quality as starlight, steady, patient, present. The Milky Way holds its stars the way sleep holds its dreams, not tightly, but with a kind of gravitational tenderness that keeps them near without constraining them. Stars move within the galaxy, slowly tracing great elliptical paths around the center, and as they move they carry their orbiting planets, their moons, their comet clouds, their vast halos of dark matter. Everything they have gathered or created trailing along beside them through the dark. Our sun makes this journey too, completing one full orbit of the galactic center roughly every 225 million years, a span of time called a cosmic year or a galactic year. And in the 4.5 billion years since our sun was born, it has completed this journey only about 20 times. 20 laps. 20 circuits through the galaxy, and in that time, life appeared on Earth, grew complex, breathed, walked, looked up, and began to wonder. 20 circuits, and here we are. The stars are not only sources of light and warmth, they are the foundries of the universe, the places where the periodic table is slowly written, one element at a time, across billions of years of nuclear fusion. In the hearts of stars, hydrogen becomes helium. In larger stars, helium becomes carbon, oxygen, neon, magnesium. In the most massive stars, the chain continues all the way to iron, the heaviest element that can be built through fusion without the process costing more energy than it releases. When iron accumulates in a stellar core, the star's long work is done. The core collapses in less than a second, and the supernova that follows seeds the surrounding space with everything the star has ever made, plus the even heavier elements forged in the violence of the explosion itself. And so the galaxy slowly enriches itself. The first stars, born when the universe was young, and the only elements were hydrogen and helium, had none of this complexity to offer. But when they died and scattered their first-generation metals into space, the next generation of stars formed from slightly richer clouds. And when those stars died, the next generation richer still, and so on, and so on. In a great slow accumulation of complexity, a patience that spans cosmic time, until eventually the clouds were rich enough to form not just stars but planets. And on at least one of those planets, the carbon and oxygen and iron assembled themselves, following the strange and beautiful logic of chemistry, into something that could breathe and feel and sleep. Every atom of iron in your blood, every grain of calcium in your bones, was forged inside a star that lived and died long before our sun was born. And this truth drifts through the mind like a warm current, settling gently as you consider how the galaxy has spent billions of years quietly. Every atom of iron in your blood, every grain of calcium in your bones was forged inside a star that lived and died long before our sun was born. And this truth drifts through the mind like a warm current, settling gently as you consider how the galaxy has spent billions of years quietly breathing itself into being, slowly and without urgency. The way a vast tide moves not with the crash and foam of a wave, but with the deep, unhurried pull of an ocean, finding its own level across the long, dark floor of time. Let yourself sink a little deeper into wherever you rest tonight, and imagine, if you can, the very beginning of this story. Not the beginning of your story, or even the beginning of Earth's story, but the beginning of the galaxy's story, which is very nearly the beginning of everything. The universe itself is approximately 13.8 billion years old, and our Milky Way, this soft, luminous river of stars that arches overhead on clear country nights, is estimated to be approximately 13.6 billion years old. That means the galaxy has been here for almost as long as the universe has existed. It is nearly as ancient as time itself. Breathe that in for a moment, the way you might breathe in cool night air, slowly feeling the lungs expand, then letting it go. 13.6 billion years. A number so enormous, it has no real purchase in the human mind. And perhaps that is just as well, because numbers of that magnitude are better felt than counted, better dreamed than calculated. In the very earliest moments after the Big Bang, the universe was a place of extraordinary simplicity. There were no stars yet, no galaxies, no planets, no moons, no quiet beaches, where the water meets the sand at dusk. There was only light and heat, and the first two elements that physics had allowed to exist, hydrogen and helium, the simplest, lightest, most elemental substances in all of creation. These gases filled the young universe in enormous, slowly cooling clouds, diffuse and vast beyond any easy imagining, stretching across distances that would make even the modern galaxy seem modest in comparison. And for a long time, for a stretch of cosmic ages that dwarfs the entirety of human civilization many millions of times over, these clouds simply drifted. They expanded with the universe. They cooled. They grew less uniform, gathering here and thinning there as the subtle architecture of gravity began to do its patient, unhurried work. It is gravity, of course, that is the great sculptor of the cosmos. Not violent, not sudden, not demanding. Gravity simply pulls and continues pulling with a persistence that knows no impatience and requires no rest. Slowly, one of these enormous clouds of hydrogen and helium began to respond to gravity's quiet insistence. It began to collapse inward, very gradually at first, as though the cloud itself were exhaling, letting go of some vast held breath. And as it collapsed, something wonderful happened. It began to rotate, not the dramatic, obvious spin of a top or a wheel, but the slow, majestic turning that arises naturally when a large, uneven cloud of gas falls inward under its own gravity, and the slight, uneven distribution of its own momentum causes different parts of it to fall at different rates and different angles, creating a gentle, inevitable rotation that would, over billions of years, flatten the cloud into the structure we now call home. This is how the Milky Way was born, from a collapsing, rotating, primordial cloud of gas in the earliest chapters of the universe's long story, when the cosmos itself was still very young and the future was an unimaginably open thing. As the cloud collapsed and spun, the densest regions within it began to heat up and ignite. The very first stars of the Milky Way flickered into existence like the first few embers catching in a fire, glowing warm and bright in the surrounding darkness. These ancient stars were made almost entirely of hydrogen and helium because those were the only elements that existed in the universe at that time. They burned hot, and they burned fast, many of them, and when they died, they scattered heavier elements into the spaces between stars, elements that had been forged in their nuclear cores. The carbon and oxygen and iron and all the other ingredients that would eventually make the planets and the creatures that walk upon them. And the galaxy, still slowly turning, incorporated these new materials into its next generation of stars, and the next, each generation a little richer in complexity than the one before. The oldest stars in our galaxy, the ones that formed nearest to that very beginning, can still be found today if you know where to look. They reside in structures called globular clusters, dense spherical gatherings of hundreds of thousands of stars arranged in beautiful, gravitationally bound spheres that orbit the galaxy like ancient satellites, some of them containing stars that are nearly 13 billion years old. When astronomers study these clusters, they are looking back through almost the entire history of the galaxy. These ancient stars are dimmer now, cooler, many of them having passed through the later stages of their lives and settled into a quiet, long-burning phase. But they are still there, still turning through their slow orbits, witnesses to an age so remote that even the Sun, which itself is 4.6 billion years old, would seem like a newcomer by comparison. There is something deeply settling about that thought, that there are stars in our galaxy that have been shining since very nearly the beginning of all things, and that they are still there tonight, above the clouds in the atmosphere and the turning curve of the Earth, quietly burning in their ancient clusters as they have always done. The galaxy grew over time, not only through the conversion of gas into stars, but through a grander, slower kind of gathering. Over billions of years, the Milky Way drew smaller galaxies toward itself, satellite galaxies and dwarf galaxies, and loose streams of stars wandering through the dark between galaxies. And it absorbed them, one by one, incorporating their stars and gas into its own growing body. Dozens of these smaller galaxies have been consumed over the course of the Milky Way's long life, their stars blending into the general population of the galaxy the way a tributary river blends into a larger one, losing its separate identity, but contributing its waters to the greater flow. This process of galactic cannibalism, which sounds dramatic but happens with almost incomprehensible gentleness over timescales of hundreds of millions of years, is one of the reasons our galaxy has grown to its current size, a broad, luminous disk roughly 100,000 light-years across, with a dense and ancient central bulge at its heart and long, graceful spiral arms trailing outward through space like the curving wake of something that turned very slowly, very long ago. Within this vast structure, astronomers have identified different layers and regions that tell different chapters of the galaxy's history. There is a region called the thick disk, a layer of stars that is puffier and more extended perpendicular to the plane of the galaxy than the flatter disk that surrounds it. And this thick disk contains the oldest disk stars, the ones that formed earliest in the galaxy's history when things were more turbulent and less settled, before the galaxy had fully organized itself into the elegant, flattened form it wears today. These thick disk stars orbit the galaxy's center in ways that are slightly different from the younger stars around them, their paths carrying traces of the more chaotic conditions in which they formed, like a person whose posture still remembers some long past difficulty even as their face shows only calm. And then there's the thin disk, the flatter, younger, more organized layer of the galaxy where most of the current star formation takes place, where great clouds of gas and dust still slowly collapse to birth new stars, where the spiral arms trace their beautiful, sweeping patterns, and where, importantly, our own sun resides. The sun is part of the thin disk population, a relatively young star by galactic standards, born about 4.6 billion years ago in the quieter, more settled era of the galaxy's middle age. Embedded in one of the galaxy's outer spiral arms, in a region that has come to be called, with a lovely kind of humility, the local arm, or sometimes the Orion arm. It is not the grandest or most central location in the galaxy. It is a quiet place, somewhat removed from the busiest and most dramatic regions near the galactic center, tucked into the outer reaches of the disk where things are a little calmer, a little more stable, where a small yellow star could spend billions of years in relative peace, slowly warming the planets that had gathered around it. This layered quality of the galaxy, the ancient globular clusters, hanging above and below the plane like old lanterns, the thick disk holding the memory of the galaxy's turbulent youth. The thin disk, where new stars are still being born even now, gives the Milky Way a kind of geological depth, the way a canyon wall holds layers of different rock, each layer recording a different era, each one resting quietly beneath or above the others, the whole sequence composing a kind of archive of time that stretches from the present all the way back to nearly the beginning of the universe. You might imagine, as you let your breathing slow and your thoughts grow softer and less defined at the edges, that you are like a small reader standing at the base of that canyon wall. Looking up at the layers, each band of stone a different age, each one a chapter of a story so long and so patient and so unhurried that it makes all of human history seem like a single line written lightly on the first page of a library that stretches beyond sight in every direction. The galaxy does not know urgency. It does not experience its own becoming. It simply turns and turns and turns, the way a great stone turns in a river, shaped by forces patient enough to accomplish over billions of years what no brief violence could ever achieve. And there is something extraordinarily peaceful in that image, this vast turning structure of stars and gas and dark matter and ancient light, assembling itself from the breath of the early universe, one drifting cloud at a time. One gentle collision of gas and dust at a time across timescales so vast that a single human life would appear as the briefest flicker of a firefly against the long, dark country night. And within all of that immensity, nestled among the outer edges of one quiet spiral arm, our own small solar system began its own long and patient journey, moving not only through space, but through time itself. carried along by forces so enormous and so gentle that we have never once felt their pull, never once sensed the breathtaking velocity at which our small blue world is being swept through the dark. Close your eyes for a moment, if you like, and imagine the ocean. Not a stormy ocean, not a restless one, but the kind of ocean you find in the deep hours of a calm night, when the water is dark and smooth and the stars above it are perfectly still, and the tide comes in and goes out in long, slow, unhurried breaths, as though the sea itself is sleeping. There is rhythm in that ocean, ancient and reliable, a rhythm older than the shores it touches, older than the names we have given to the waves. And it is with something like that rhythm that our solar system moves through the Milky Way, carried on a current so immense that no single human mind can truly hold it, and yet so steady and so soft that we have lived our entire history without ever feeling a single tremor of it beneath our feet. Right now, at this very moment, as you lie still and let the quiet settle around you, our solar system is traveling through the galaxy at a speed of approximately 828,000 kilometers per hour. Let that number breathe for a moment. 828,000 kilometers every single hour. And yet here you are, perfectly still, perfectly at rest, the air around you undisturbed, the world outside your window silent and unmoving. There is something almost magical in that contradiction, something that invites a kind of wonder so soft it feels less like astonishment and more like peace. We are hurtling through the cosmos at a speed that would carry us around the entire Earth more than 20 times in a single hour, and we feel nothing. We notice nothing. The stars above us appear fixed and faithful as old friends, and the ground beneath us feels as solid and unhurried as it has always felt, and there is no whisper in the wind, no trembling in the stone, to suggest that anything at all is moving. This is because everything around us is moving together, all at once, all in the same great sweeping arc. The way a school of fish turns as one body through the water without any individual fish noticing the turn. The way a cloud drifts across the sky without the water droplets inside it feeling the drift at all. We are not moving through the galaxy the way a stone skips across a pond, leaving ripples, disturbing the surface. We are moving with the galaxy, part of its slow and breathing pattern, one small piece of a structure so vast that to describe it fully would take longer than the universe has so far existed. And even at that extraordinary speed, 828,000 kilometers per hour, even moving that fast through the dark, it still takes our solar system somewhere between 225 and 250 million years to complete a single full orbit around the center of the Milky Way. Astronomers have given this extraordinary measure of time a name. They call it a galactic year, or sometimes a cosmic year. And there is something beautifully humbling in the idea that a year can mean something so incomprehensibly different depending on where you stand to count it. Our Earth year, the one we use to mark birthdays and seasons and the turning of our lives, is 365 days. A galactic year is 250 million of them. It is a year measured not in sunrises, but in the slow breathing of an entire galaxy, not in seasons, but in the rising and falling of mountain ranges, the drifting of continents, the coming and going of entire chapters of life on Earth. Think of it this way. The last time our solar system was in approximately the position it now occupies in its great galactic orbit, life on Earth was doing something it had never done before. The first dinosaurs were only just beginning to appear. stepping cautiously into a world still warm and strange with the aftermath of one of the greatest extinction events our planet had ever experienced. The ancient supercontinent of Pangaea was beginning its long, slow separation into the pieces we now call continents. The shallow seas were filling with creatures that bore no names, that no eye had ever observed, that left their marks only in stone and deep time. That was one galactic year ago, one full lap around the center of the Milky Way, and in that time, the dinosaurs rose and flourished for 160 million years and then vanished. And the mammals that survived inherited a transformed world. And among those mammals, something small and curious eventually looked up at the stars and began to ask questions. All of that, the entire pageant of recognizable life on our planet, within a single galactic year, within one slow orbit of a star around a galaxy. It makes the mind go quiet, doesn't it? Not with the sharp vertigo of something frightening, but with the softer stillness of something profoundly true. We are so small and the universe is so patient, and somehow the smallness and the patience fit together like two hands folded in the dark. But the journey of our solar system through the Milky Way is not simply a flat circle, not a clean and level path like a track around which runners move. There is something more rhythmic about it, something more oceanic, and this is the part that feels when you sit with it quietly, almost like breathing. As our solar system makes its long arc around the galactic center, it also bobs gently up and down through the galactic plane, rising above the flat disk of the Milky Way, and then dipping slowly below it, over and over in a motion that takes tens of millions of years for each oscillation. Scientists sometimes describe this as being like a horse on a carousel, rising and falling as the carousel turns, and there is something right about that image. Something that captures the combination of forward motion and vertical rhythm. The way the movement is simultaneously circular and wave-like. The way it has a pulse to it as well as a sweep. Imagine lying in shallow water at the edge of the sea, the ocean floor just barely beneath you, and feeling the slow swell of each wave lift you gently upward and then settle you back down. Lift and settle. Lift and settle, over and over in a rhythm so slow and so large that between each rising and each falling, you might almost forget the motion was happening at all. That is something like what our solar system does as it orbits the galaxy, rising above the galactic plane and then sinking back through it, carried in a motion that is simultaneously vast and gentle. Dramatic and imperceptible, a breathing that happens on timescales so long they belong more to geology than to astronomy. And as our solar system moves through this great galactic orbit bobbing softly up and down, it passes through regions of the Milky Way that are more crowded, more dense with the material of stars and nebulae and the ancient compressed clouds of gas that are the galaxy's raw material. The Milky Way is a spiral galaxy, which means it has arms, great sweeping structures curving outward from its center, like the arms of a slow pinwheel, denser and brighter than the spaces between them. Rich with young stars and with the dust and energy of ongoing creation. And as our solar system completes its long orbit, it passes through these denser spiral arms, moving through them the way a boat moves through a patch of thick kelp in the ocean, feeling a change in the texture of the surrounding water, a difference in what lies close and what lies far. Some scientists have looked at the timing of our solar system's passages through these denser spiral arm regions and noticed something quietly remarkable. There seems to be a pattern, still debated and still being studied with great care, but a pattern nonetheless. in which the times when our solar system was moving through the denser parts of the galaxy seemed to correspond, at least loosely, with periods of increased cosmic radiation reaching Earth, with changes in the environment of our inner solar system, and possibly even with some of the great extinction events that have punctuated the history of life on this planet. The idea is that when the solar system passes through a denser region of the galaxy, it encounters more supernovae in its neighborhood, more cosmic rays streaming through space, perhaps changes in the cloud of particles that surrounds and partially shields our solar system from the deepest reaches of interstellar space. And those changes, subtle as they might be across millions of years, could have rippled down through the atmosphere, through the climate, through the delicate balancing act that keeps life flourishing on a small rocky world. It is a humbling thought to sit with, the idea that something as enormous as our galaxy's spiral structure might have left fingerprints on the history of life on Earth, that the extinctions and the renewals, the great dyings and the great flowerings, might have been shaped in part by the path our solar system traced through the arms of its home galaxy over hundreds of millions of years. It does not make those losses less real or less painful in the telling, but it places them inside a larger story. A story that is not about catastrophe, but about continuity, about the way life on this planet has always found a way to continue, to adapt, to fill the space left behind, to try again in new forms and new configurations, generation after generation, galactic year after galactic year. And through all of it, through every extinction and every renewal, through every age of ice and every age of warmth, through the long rule of the dinosaurs and the slow rise of the mammals and the briefer, still appearance of the curious creatures who now look up at the stars and tell stories about them. Through all of that immensity of time and change, our solar system has continued its quiet journey. It has not paused. It has not faltered. It has moved along its great arc around the galactic center at 828,000 kilometers per hour, rising and falling through the galactic plane with the slow rhythm of a breath, passing through the denser arms of the galaxy and out again into the quieter spaces between them, carrying with it everything we have ever known, every story ever told, every face ever loved, every question ever asked beneath a night sky. There is something deeply restful in that continuity, something that feels less like the indifference of the universe and more like its steadiness. The galaxy does not hurry. The orbit does not waver. The rhythm of rising and falling through the galactic plane continues without urgency, without drama, as regular and reliable as the tide coming in and going out on a shore where no one is watching. And we are part of that rhythm, have always been part of it, will continue to be part of it for as long as our small world holds its thin envelope of air and keeps its oceans liquid and goes on turning in the dark. Sometimes, in the quietest part of the night, when the mind is soft and the body is still, and the boundary between waking and sleeping has begun to grow pleasantly uncertain, it is possible to feel something that might be the ghost of that motion. Not a physical sensation, nothing so crude as that, but something more like an intuition, a sense of being carried, gently and without effort, through something enormous and dark and beautiful. The way you feel sometimes on the edge of sleep, as though the bed beneath you has become very slightly larger than the room, as though the walls have quietly dissolved and left you floating in something vast and quiet and safe. That feeling, that soft dissolution of the boundary between self and space, is perhaps the closest our small human bodies can come to knowing what our planet is actually doing at every moment. moving through the galaxy at impossible speed, riding a great and ancient current, part of a rhythm so large and so slow that it has no name in any human language except perhaps the word forever. And so our solar system continues its journey, unhurried and unceasing, around the glowing heart of the Milky Way, and the galactic year turns as slowly as a dream, and the spiral arms drift past like slow tides, and the whole vast structure breathes and wheels in the dark, and we are carried with it, warm and small and alive. Our solar system rides this great slow carousel without any sensation of motion at all, the stars around us appearing fixed and eternal from our tiny vantage point. Just as a traveler on a vast and glassy sea might feel perfectly still, even while carried gently forward by a current older than any map. And all around our moving world, the galaxy breathes and hums with the soft energy of something vast and invisible, a medium through which all starlight must pass, a breath held between the fires. And it is into this breath that we now drift, quietly, the way a dream dissolves one landscape and offers another without any clear boundary between them, until you find yourself somewhere entirely new and cannot quite remember the crossing. Between the stars, you might imagine there is nothing, pure emptiness. A void so complete and so cold that nothing could survive within it. Nothing could linger or drift or belong. And in the oldest imaginations of the cosmos, that is perhaps how people thought of it. The stars as bright islands separated by absolute nothingness. The darkness between them merely the absence of light and presence and meaning. But the universe has always been more generous than our assumptions about it, more layered and more strange. And the truth of what lies between the stars is something far more beautiful and subtle than simple emptiness could ever be. The space between stars in our galaxy is filled, not densely, not in any way you could touch or see or feel if you were floating through it, but filled nonetheless with what astronomers have come to call the interstellar medium, a word that sounds clinical and distant, but which describes something almost poetic in its nature, a medium in the truest sense, something that exists between, something that carries and connects. Something that is neither the bright fire of a star nor the hard surface of a world, but the in-between stuff, the connective tissue of the galaxy itself. Think of it the way you might think of air on a quiet autumn night. You cannot see air. You cannot hold it in your hands or weigh it with your eyes. But it is there, surrounding everything, touching everything, carrying the scent of fallen leaves and the distant sound of water and the particular coolness that belongs only to that hour before the first frost. The interstellar medium is something like that, except it is stretched across distances so incomprehensibly vast that the density we are talking about is almost impossible to translate into human terms. In the best vacuum a laboratory on Earth can produce, there are still millions of molecules per cubic centimeter. In the interstellar medium, in its most rarefied regions, there may be only one atom per cubic centimeter, sometimes fewer. It is emptier than anything we can make, and yet it is not empty at all. It is a mixture of gas and dust and plasma, of charged particles and quiet molecules of light and shadow and magnetic fields threading through everything like invisible silk. And of all of it, the vast majority, something close to 99%, is gas, primarily hydrogen, the oldest and most abundant element in the universe, the element that was forged in the first 3 minutes after the beginning of everything and has been traveling through space and collapsing into stars and drifting free again ever since. Alongside the hydrogen drifts helium, the second element, almost as ancient, and together these two make up nearly all of the gaseous component of the interstellar medium. A vast ocean of the universe's original ingredients, still moving, still available, still patient, and waiting for the next chapter of their long story. And then there is the remaining 1%, the dust. And it would be a mistake to let that small fraction fool you into thinking it is unimportant. 1% of the interstellar medium is cosmic dust, and while it sounds like a trivial quantity, it is responsible for some of the most visible and extraordinary features of the night sky. These dust grains are incredibly tiny, smaller than you might imagine when you hear the word grain, roughly the size of particles in cigarette smoke, each one a fragment of carbon or silicate or ice, something forged in the outer layers of dying stars and expelled into space when those stars breathed their last enormous breath. They drift in the dark between the stars. These particles smaller than anything you could see with the naked eye, and yet when they gather in sufficient numbers, when they accumulate in the long lanes and corridors of the galaxy, they become visible in their own way, not by glowing, but by blocking, by absorbing and scattering the light of the stars behind them. This is why the Milky Way, when you look at it on a clear, dark night, is not a smooth and uniform band of light, but something interrupted, something patchy and uneven, threaded with dark rivers and shadowed canyons that seem to cut through the brightness. Those dark patches are not holes in the galaxy. They are not places where stars have gone out or where space has somehow emptied itself. They are clouds of interstellar dust so thick and so concentrated that the starlight from behind them cannot reach us, absorbed and scattered by countless trillions of tiny particles drifting in the quiet dark. The darkness you see is a presence, not an absence. It is matter announcing itself by the light it refuses to let through. And there is another thing the dust does, something you can notice if you look at the stars near those dark lanes, the stars at the edges of the dust clouds, the ones whose light must travel through the thinner outer regions of those dusty corridors to reach your eyes. They look redder than they should, not because they are red stars, not because their own fires are cooler or dimmer, but because the dust grains scatter shorter wavelengths of light more efficiently than longer ones. Blue light gets scattered away, deflected sideways and lost, while red light slips through more easily, continuing its journey toward you. The result is that distant stars seen through interstellar dust appear reddened, tinged with a warmth that comes not from their own nature, but from the long filtering passage of their light through the medium between you and them. The universe is painting the sky, and the paint is dust too fine to see, doing its quiet work across distances too vast to walk. The interstellar medium is not uniform. It is not a single thing with a single character. It is instead a landscape of extraordinary contrasts, as varied and dramatic in its way as any terrain on Earth, though spread across scales that dwarf any geography we have words for. There are regions of the interstellar medium where the gas has been heated to extraordinary temperatures by the shock waves of supernova explosions or by the fierce radiation pouring from young, massive stars. In these regions, the gas exists as plasma, its atoms stripped of their electrons, moving so quickly and colliding so violently that temperatures climb to millions of degrees. Millions of degrees in the space between stars. It sounds violent, almost incompatible with the gentle image of a sleeping galaxy, and yet even this plasma is so diffuse, so thin, that a human body passing through it would feel nothing, would not be warmed at all, Because warmth requires contact with sufficient numbers of particles, and here the particles are so sparse that the heat has almost nothing to carry it from place to place. And then, not far away in the vast geography of the interstellar medium, in the same galaxy, in the same slow cosmic neighborhood, there are regions of a completely different character. Cold, extraordinarily cold. Molecular clouds where the gas has clumped together under gravity, where the dust has gathered so thickly that starlight cannot penetrate, where temperatures plummet to just a few degrees above absolute zero, close to minus 270 degrees Celsius, as cold as anything in the universe gets, as close to the complete cessation of molecular motion as physics allows. These are the cold, dark hearts of the interstellar medium, the giant molecular clouds, some of them stretching hundreds of light years across, containing more mass than 1,000,000 suns, sitting in the quiet dark like sleeping giants, like held breath, like the last moment of stillness before something changes. Between these extremes, the interstellar medium passes through every intermediate temperature and state. There are warm regions and cool regions, diffuse regions and dense ones, places where hydrogen exists as individual atoms and places where it has formed molecules, bonded pairs drifting in the cold, and places where it has been ionized by starlight into plasma. And all of these different phases exist together in the galaxy, flowing and shifting and transitioning from one state to another over timescales that would make human civilization look like a brief afternoon nap. What moves through all of it, connecting these different regions and threading them together, is the light of stars. Starlight travels through the interstellar medium, and as it travels, it interacts with what it finds. It ionizes gas near hot young stars, creating glowing regions called nebulae, clouds of gas lit from within by the fierce radiation of newly born suns, shining in pinks and greens and blues that seem almost too vivid to be real, but are entirely and precisely real. The colors determined by the specific atoms being excited and the specific wavelengths of light those atoms emit when they calm themselves again. The Orion Nebula, which you can see with your naked eye on winter nights as a soft smudge near the sword of that ancient constellation, is one of these places, a knot of glowing interstellar gas being lit up by young stars within it, a nursery announcing itself with light. Because this is the other great truth about the interstellar medium, the truth that perhaps matters most of all in the long story of the cosmos. The giant molecular clouds within it, those cold, dark regions where temperatures hover near absolute zero and where dust has blocked out all external light, are the birthplaces of new stars and the planetary systems that may one day accompany them. The interstellar medium is not merely the space between the old fires. It is the raw material for the next generation of them. Every star that has ever shone, every planet that has ever turned in the warmth of a sun, every ocean and every mountain, and every brief life that has ever existed began its story in the interstellar medium, in a cloud of gas and dust that eventually gathered itself, pulled together by gravity, compressed and heated until the moment that the first nuclear fires ignited in its center and a new star was born. This has happened billions of times in our galaxy alone. It is happening right now, in molecular clouds scattered across the spiral arms of the Milky Way, in places where gas has grown dense enough and cold enough for gravity to win its patient argument against pressure and radiation, in the deep, quiet dark where nothing appears to be happening, but everything is beginning. The interstellar medium is the universe's memory and its intention at the same time. It holds the ash of dead stars and the seeds of stars not yet born. It is past and future dissolved in the same thin, drifting, extraordinary substance. When you look up at the night sky and see the Milky Way on a clear night, you are seeing starlight that has passed through the interstellar medium to reach you. Some of it has been reddened, some of it has been absorbed entirely. The dark patches you see are the dust clouds doing their ancient work, and behind them, invisible to your eyes, are the molecular clouds, and within those clouds, the processes of star formation are proceeding with their slow and magnificent patience. You're looking at a process rather than a picture. You're watching a story that has been unfolding for 10 billion years and shows no sign of concluding, a story of matter cycling between stars and the spaces between them, of elements being made in stellar cores and scattered into the interstellar medium when those stars die, of that scattered material being gathered again by gravity into new clouds and eventually into new stars and new worlds. The dust that drifts in the interstellar medium carries within it the elements that were forged in previous generations of stars: carbon and oxygen and silicon and iron and every other element heavier than hydrogen and helium. All of it was made inside a star, somewhere, sometime. And when that star died, it was expelled into the interstellar medium, where it mixed with the primordial hydrogen and helium, where it was incorporated into dust grains no larger than the finest smoke, and where it waits now, drifting in the immense silence between the fires, for the next gathering, the next compression, the next moment when gravity will pull it all together again into something new, something warm and bright and burning, or perhaps into something smaller and colder and rocky, something like a world, something like a home. This is the gentle and extraordinary truth of the space between stars. It is not empty. It is not dead. It is the medium through which the galaxy breathes, the substance in which the past dissolves and from which the future quietly assembles itself, populated by countless trillions of dust grains, each one smaller than a grain of beach sand, drifting in the long silence between suns, carrying within them the elemental memories of ancient stellar fires. And in the densest and coldest of these clouds, something extraordinary and patient is always beginning. A slow gathering, a quiet pulling together of matter that will one day become countless trillions of dust grains, each one smaller than a grain of beach sand, drifting in the long silence between suns, carrying within them the elemental memories of ancient stellar fires. And in the densest and coldest of these clouds, something extraordinary and patient is always beginning, a slow gathering, a quiet pulling together of matter that will one day become a new star, a new sun, perhaps a new world circling in the warmth of its light, and yet surrounding all of this visible creation, woven through every arm and cloud and cluster of our galaxy. There persists something we cannot see or touch or measure directly, something whose presence we know only by the way it bends the paths of everything around it, like a current felt beneath still water, a depth you sense before you see it, a weight in the darkness that holds everything tenderly in place without ever revealing its face. There is a quality to standing at the edge of a very deep lake at night, when the water is black and perfectly still, and the stars above are reflected so precisely in its surface that you can no longer be entirely certain which direction is up, which is down, which is heaven, and which is simply its quiet mirror. You feel the water pulling at something inside you, not with violence or urgency, but with a kind of ancient patience. You feel that whatever lives beneath the surface has always been there long before you arrived and will remain long after you have gone. That is something like the feeling the universe asks us to sit with when we turn our attention to dark matter. That vast, invisible, and utterly humbling presence that surrounds and suffuses our galaxy, holding it together with a gravity we can measure, but whose source we have never once laid eyes upon. Our galaxy, the Milky Way, that great luminous river of stars you can sometimes see arching overhead on a clear night far from city lights, is beautiful and ancient and staggeringly large. It stretches across roughly 100,000 light years, a number so enormous it becomes almost meaningless without a moment of quiet contemplation. It contains hundreds of billions of stars, each one a sun, many of them circled by their own families of worlds. It holds clouds and corridors of gas and dust, nurseries of new stars and graveyards of old ones, globular clusters orbiting like slow pearls, and nebulae, glowing in colors that seem almost too vivid to be real. And yet, for all of this, for all of its breathtaking visible grandeur, what we can actually see represents only a small fraction of what is truly there. Approximately 85% of the total mass of the Milky Way is believed to be dark matter. Not 85% of some small peripheral region, not 85% of some unusual and isolated structure, but 85% of the total mass of everything our galaxy contains. The stars and the planets and the nebulae and the dust and the gas and every black hole and every wandering comet and every grain of cosmic debris that has ever drifted through our home galaxy. All of it together, all of that magnificent visible creation, accounts for only roughly 15% of what is actually here. The rest, the vast, overwhelming, silent majority of our galaxy's mass, is composed of something we have never detected, never photographed, never captured in any instrument. We call it dark matter, and the name itself is a kind of confession. We call it dark, not because it is sinister or dangerous, but simply because it emits no light, reflects no light, absorbs no light. It does not interact with electromagnetic radiation in any way that we have ever been able to observe. It is, in the most literal sense, invisible to everything we have ever built to see with. And yet we know it is there. We know it with a confidence that decades of careful and rigorous science have earned, because even though dark matter refuses to speak to us in light, it speaks to us in gravity, and gravity, as it turns out, is a language we have learned to read with remarkable precision. The story of how we first began to suspect this invisible presence is itself a story worth lingering over, because it began not with some grand theoretical proclamation or some dramatic discovery, but with a quiet, persistent, and extraordinary act of attention. In the 1970s, an astronomer named Vera Rubin was studying the rotation of galaxies, measuring how fast different parts of a galaxy move as they orbit around the galactic center. There is a simple and elegant expectation that physics gives us for this kind of rotation. Stars and material closer to the center of a galaxy, where most of the visible mass is concentrated, should orbit quickly. Stars and material in the outer regions, far from the center, should orbit more slowly, just as the outer planets of our solar system move more slowly around the sun than the inner ones do. This is not a strange or exotic prediction. It is simply what gravity does, what it has always done, what Newton and Einstein both agreed it should do. But that is not what Vera Rubin found. When she measured the rotation of galaxies, she found something that should not have been possible given what was visible. The outer regions of galaxies were not slowing down as expected. They were rotating far faster than they should have been, moving so quickly that if only the visible matter were present to hold them gravitationally, those outer stars should have been flung out into intergalactic space long ago. The galaxies she observed had no right to hold together the way they did, not unless something else was there, something massive and invisible, providing the gravitational scaffolding that kept everything in place. Rubin's discovery was not immediately celebrated, as is so often the case with ideas that require us to revise our understanding of something fundamental. But the evidence she accumulated was patient and meticulous and eventually undeniable, and over the following decades, observation after observation, from many different directions and many different kinds of instruments, all arrived at the same conclusion. There is more mass in these galaxies than we can see. There is something here that we cannot find with light alone. Our own Milky Way is surrounded by what scientists call a dark matter halo, and the word halo here carries a kind of accidental poetry, suggesting something luminous and ethereal, when in fact, what it describes is precisely the opposite, a vast spherical cloud of invisible mass extending far beyond the visible disk of our galaxy. The stars and gas and dust that we can observe, the beautiful spiral arms stretching out across 100,000 light years, are in a sense just the glowing center of something much larger and far less visible. The dark matter halo extends outward to perhaps 10 times the diameter of the visible galaxy, a colossal and silent envelope of unknown matter within which our entire galaxy is cradled. It is not a shell or a surface. It is a volume, a three-dimensional presence interpenetrating and surrounding everything we have ever seen when we look up at the night sky. And despite everything we know about its effects, despite decades of searching with instruments of extraordinary sensitivity, despite underground laboratories buried miles beneath the surface of the Earth where scientists have waited in the deep quiet for any whisper of a dark matter particle passing through their detectors, despite experiments in orbit and in deep mine shafts and in the most sterile and isolated physics laboratories humanity has ever constructed, we have not directly detected a single dark matter particle, not one. Its existence is inferred entirely from its gravitational effects, from the way galaxies rotate, from the way light bends around clusters of galaxies, from the way the large-scale structure of the universe itself formed, all of which point unmistakably to a vast presence of something we cannot touch. We have names for what dark matter might be, which is itself a remarkable thing. To name something you have never encountered, to theorize about the properties of something whose only known quality is that it resists all your instruments while quietly shaping everything around you. Among the most studied theoretical candidates are particles called WIMPs, weakly interacting massive particles, which would be substantial in mass but almost entirely indifferent to ordinary matter, passing through walls and planets and stars and human bodies in their countless billions without ever leaving a trace. And then there are axions, particles so light and so elusive they make WIMPs seem practically sociable by comparison. Extremely light particles that some theories of fundamental physics suggest might exist in such unimaginable numbers that their combined mass could account for the dark matter we observe. Both of these remain hypothetical. Both remain stubbornly undetected. The experiments searching for them are among the most sophisticated and painstaking in all of science, and they continue year after year with a dedication that is itself a form of reverence, a willingness to sit with the unknown for as long as it takes, to keep listening at the edge of the deep water, even when the water gives nothing back but its own patient silence. There is something quietly profound about this situation, something that asks us to hold two things at once. We live inside a galaxy that is mostly invisible to us. The home we inhabit, this great island of stars in which our own small sun is just one among hundreds of billions, is constituted primarily of something we have never seen and cannot touch and have not yet been able to understand. The beautiful light-filled structure we call the Milky Way, the thing we have mapped and named and sung about and navigated by for all of human history, is something like the visible surface of a far vaster and far older and far more mysterious presence. We are, in a sense, guests in something much larger than we can perceive. And there is a gentleness to this thought. If you let it settle slowly, if you breathe with it rather than pushing against it, because the dark matter halo is not an absence. It is not a void or a lack. It is a presence, a holding, a vast gravitational embrace that has kept the Milky Way together across billions of years, that has allowed the stars to form and the planets to orbit, and the long patient work of chemistry and time to arrive, eventually, at something capable of wondering about it. The invisible 85% is what made possible the visible 15. The darkness in this sense is not opposed to the light. It is what allowed the light to gather and persist. You might close your eyes now and imagine yourself floating gently in the middle of this halo, surrounded not by stars or gas or any visible thing, but by that vast and quiet presence. Invisible particles streaming through you in their countless trillions, indifferent and ancient, present before the first human eye ever opened, and present still, patient as stone, patient as deep water, patient as the space between thoughts in the long and restful quiet of the night. You would feel nothing, you would see nothing, and yet you would be held as you always have been, as everything has always been, by something older and larger and more mysterious than the light. The Milky Way turns slowly in its halo, the visible spiraling within the invisible, the known cradled within the unknown, and at the center of one of its great sweeping arms, a yellow star burns steadily, and around it, a small blue world carries its passengers through the dark. And those passengers look up into the night and ask questions. And the darkness listens with its deep and patient attention. And the questions float outward like light, like warmth, like the very oldest kind of hope. And in the clouds of gas and dust drifting between the stars of that same galaxy, in the cold and quiet regions where gravity is slowly winning its ancient argument with emptiness, matter is gathering, as it has always gathered, tending toward a new star, a new sun, perhaps a new world circling in the warmth of its light, and yet surrounding all of this visible creation, woven through every arm and cloud and cluster of our galaxy. There persists something we cannot see or touch or measure directly, something whose presence we know only by the way it bends the paths of everything around it, like a new star, a new sun, perhaps a new world circling in the warmth of its light, and yet surrounding all of this visible creation, woven through every arm and cloud and cluster of our galaxy. There persists something we cannot see or touch or measure directly, something whose presence we know only by the way it bends the paths of everything around it, like a gentle hand that never shows itself, but whose touch you feel in every turning, every curving path, every orbit that refuses to unravel into open space. And it is in part because of this invisible embrace, this quiet gravitational architecture holding everything in place, that our galaxy is not alone in the dark. It is held, as so many things in this universe are held, within something larger than itself. Imagine, if you will, that you could step back from our Milky Way, the way you might step back from a lamp in a darkened room, pulling away until the light itself becomes small, until it becomes one glow among several scattered across an immense and velvet floor. What you would see in that impossible withdrawal is that our galaxy is not isolated. It belongs. It is a member of a quiet congregation of galaxies, dozens upon dozens of them, all loosely gathered and gravitationally bound, all slowly turning and drifting within a shared cosmic neighborhood that astronomers have named, with a kind of humble simplicity, the local group. The local group contains more than 54 galaxies, each one a distinct and extraordinary world of its own, some enormous spirals wheeling majestically through the dark, and others so small and faint that they seem almost like whispers, like afterthoughts scattered between the larger voices. There are dwarf galaxies here, small companions that orbit their larger neighbors the way moons orbit planets, and there are irregular galaxies shaped by ancient collisions and gravitational tugging, their stars arranged not in the elegant spirals we admire, but in looser, more wandering patterns. All of them together form this local group, this gravitationally bound family, spread across a region of space roughly 10 million light-years in diameter. Each galaxy moving and breathing and evolving in its own way, and yet all of them connected by the invisible threads of mutual gravity, all belonging to the same soft gathering in the dark. Within this family, our Milky Way is one of the larger members, a great spiral of some 200 to 400 billion stars turning slowly on its axis, its arms curving outward through the dark. But there is another member of this family that is larger still, another great spiral that hangs in the night sky of our world as a faint and barely visible smear of ancient light. And this galaxy is one that has been known to human eyes for as long as human eyes have turned upward in wonder. It is called the Andromeda Galaxy, known also by its catalog name Messier 31, and it is our nearest large galactic neighbor, our closest companion among the giants of the local group. Andromeda is vast. It stretches across space with a diameter larger than our own Milky Way, its disk of stars and dust and gas spread wide across the dark, its own spiral arms curving outward from a bright and ancient core. And it is far away, as almost everything in the cosmos is far away, separated from us by a distance so immense that the light we see from it tonight left that galaxy 2.5 million years ago, before the first stone tools were shaped by the first human hands, before any creature on this small blue world had ever looked up and wondered. The light arriving at your eyes. If you were to stand outside on a clear, dark night and find Andromeda with your gaze, that light has been traveling since before our species existed, crossing 2,537,000 light-years of open space to reach you, to land gently on the surface of your eye, to become in some small way part of you. There is something tender in that thought, something quietly moving about the fact that ancient light can travel so far and still find a living creature willing to receive it. Andromeda and the Milky Way are neighbors in the truest sense that cosmic scale allows, separated by distance that is enormous by any human measure and yet close. relative to the vast scales of the universe, close enough that they can see each other, close enough that their gravity reaches across the space between them, close enough that they are, in the most profound and patient sense, drawing together. Because they are approaching each other, the Milky Way and Andromeda are not sitting still in the dark, not merely coexisting at a fixed distance across the void. They are moving toward one another, drawn by the mutual pull of their combined gravity, falling slowly and inexorably together through the space that separates them. The speed of this approach is not slow by ordinary human standards. They close the distance between them at approximately 110 kilometers every second, which is a number that sounds startling until you remember the scale involved. Until you remember that the space between them spans more than 2 million light years. At 110 kilometers per second, it will still take an almost inconceivably long time for them to reach each other. The expected moment of their meeting, if meeting is the right word for something so vast and gradual, lies approximately 4.5 billion years from now. 4.5 billion years. Let that number settle over you the way a blanket settles over a sleeper, gently, warmly, without urgency. It is a span of time longer than the Earth has existed, longer than our sun has been burning, a duration so immense that the word distant barely touches it. And yet, within the patient logic of the universe, 4.5 billion years is simply a season, a long turning of cosmic time, after which two old neighbors will finally come together. When they do, when the leading edges of these two great spiral galaxies finally begin to overlap and interpenetrate, what will happen will be nothing like the collision you might imagine if you placed two objects together in the ordinary world. There will be no crash, no catastrophic smashing of stars into stars, no tremendous explosion visible across the universe. And the reason for this comes back again to something we have touched on before, to the extraordinary emptiness of the space within a galaxy. Even within a galaxy as rich and crowded seeming as the Milky Way, the stars themselves are so sparsely distributed, so enormously far from one another even when measured against their own diameters, that the probability of any two individual stars actually colliding during the galactic merger is vanishingly small. Our own sun, for instance, is more than 4 light years from its nearest stellar neighbor, a distance so great that even as the galaxies merge and their stars begin to intermingle, most of those stars will simply pass through the spaces between each other, missing each other by astronomical margins, drifting on undisturbed. What will happen instead is something far more graceful, far more poetic in its way. The two galaxies will pass through each other, their stars weaving between each other like two different flocks of birds flying through the same airspace. Each member of each flock finding the gaps between the members of the other. The space is large enough that no one collides, and then, drawn back by gravity, they will turn and approach again, and pass through each other once more, and gradually over hundreds of millions of years. They will spiral together more and more tightly, their shapes distorting, their arms stretching and curling, and eventually losing the clean spiral structure that both galaxies currently wear, until at last the two galaxies have merged into a single new structure, a new kind of galaxy altogether. That new structure will not be a spiral. The elegant pinwheel shape, the curved arms sweeping outward through the dark, is something that merger will dissolve, replacing it with a more rounded, more diffuse form. Scientists expect that what emerges from the union of the Milky Way and Andromeda will be a giant elliptical galaxy, a great soft oval of stars without prominent arms or disk. Its members distributed in a rounder, warmer cloud of ancient light. And this new galaxy has already been given a name that carries within it a kind of gentle humor, a small human touch affixed to something unimaginably grand. Some scientists have called it Milkomeda and others Milkdromeda, a portmanteau that holds both parents within it, a name that acknowledges ancestry while describing something new, something that has never existed before in all the history of this corner of the universe. Milkomeda, even the sound of it is soft. Say it quietly to yourself and hear how it blends the two names together, how it suggests continuity rather than destruction, inheritance rather than loss. Both galaxies will persist within it, their stars redistributed and rearranged, but still present, still burning, still perhaps warming worlds that circle them, still carrying forward whatever threads of complexity and chemistry and possibility have been woven into them over billions of years of separate evolution. The merger is not an ending. It is a transformation, a becoming. The universe rearranging itself into a new form with the same patient creativity it has always shown. And our sun, if it still burns by then, which is uncertain, given that it too is aging, given that in roughly 5 billion years it will exhaust the hydrogen at its core and expand into a red giant before eventually collapsing into a white dwarf. But let us imagine for a moment a star in the region where our sun now burns. A star perhaps born from the same molecular cloud that once held the seeds of our own solar system, carrying perhaps a world or worlds in its orbit. That star and those worlds will ride through the entire merger as through a vast, slow dream. The surrounding sky changing over millions of years as new constellations appear, as the light of Andromeda grows from a faint smear into something enormous and luminous overhead, as the familiar patterns of our own galaxy distort and shift and eventually resolve into the new and different architecture of Milkomeda. It will not be a violent or sudden transformation for any individual world. It will simply be time, passing, as time always passes, slowly and without announcement. There's something in this that feels, if you let it, less like catastrophe and less like loss and more like what it truly is, which is the universe doing what it has always done, gathering things together, building larger structures from smaller ones, finding new forms to inhabit, new arrangements to try. The local group itself, this family of more than 54 galaxies of which both the Milky Way and Andromeda are currently members, is itself a kind of rehearsal for this merging tendency. A collection of gravitationally bound neighbors slowly being drawn toward a common center over cosmic time. The small galaxies have already been merging with the larger ones throughout history. Our own Milky Way wears the evidence of ancient mergers in its structure in streams of stars that were once part of smaller galaxies absorbed long ago, in the irregular distribution of its stellar populations, in the slight warp of its disk. The galaxy we live in today is already a composite, already a merged and blended thing, and Milkomeda will simply be the next step in that long process of cosmic accumulation. And so these two great island universes, each carrying hundreds of billions of suns, will one day drift into each other's embrace across the measureless dark. Not with violence, but with the slow and inevitable grace of two clouds merging on a still summer evening. And by the time that meeting comes, our own small world will have been carried through so many more quiet galactic years So many more slow revolutions around a center of ancient stillness, that all the stories ever told beneath our stars will have become as distant and soft as the oldest lullabies, half-remembered and wholly beloved, hummed beneath a sky that has always been turning, always been vast, always been silently and tenderly home. And home is perhaps the most luminous word of all, when you hold it up against the dark and let it catch the light. We live inside a galaxy. This is a fact, so familiar that it has nearly lost its power to astonish, worn smooth by repetition the way a river stone is worn smooth by the endless patient passing of water. But hold it gently for a moment, the way you might hold something small and warm in the cup of your hands, and feel again what it means. We live inside a galaxy, not near one, not in the neighborhood of one, not orbiting at a comfortable distance where we might observe it through a window with appropriate scientific detachment. We are inside it, woven into it, threaded through with its light and its gravity and its ancient turning, the way a single word is woven into a poem without which the poem would not be itself. The Milky Way is our home in the most complete and encompassing sense. Every human being who has ever drawn breath upon this earth has done so beneath the same slow river of stars. Every child who ever looked up from a hillside in wonder. Every sailor who ever steered by the cold and steady light of the sky. Every philosopher who ever sat in the dark and tried to understand what it means to exist. All of them looked up into the same galactic family. All of them were held inside the same vast and tender structure. Whether they knew it or not, whether they had a name for it or not, the Milky Way was arching over the first fires ever kindled. It was turning above the first cities, above the first songs, above the first moments of grief, and the first moments of joy so overwhelming they had no name. It was there before we were, and it will be there long after, a slow and patient presence that asks nothing of us and offers everything simply by existing. When you lie beneath an open sky on a clear night, away from the soft orange glow of the cities, and you look up at that great pale river of light that seems to pour from one horizon to the other, you are seeing something almost impossible to hold in the mind all at once. What you see as a smear of silver is in truth hundreds of billions of individual stars, each one a sun, many of them with their own families of worlds spinning in patient attendance. And the light reaching your eyes from the bright swelling heart of that river, from the dense and luminous core where the oldest stars crowd together, and the ancient center pulls everything into its quiet orbit. That light left its source 26,000 years ago. 26,000 years. When that light began its journey toward your eyes, human beings were painting animals on the walls of caves by firelight, or crossing land bridges between continents. We're learning the shapes of seasons and the language of the sky for the very first time. That light has been traveling through the dark all this time, carrying its ancient information, patient and unhurried, waiting to arrive at this exact moment, at these exact eyes, at this exact night, where you are lying still and letting the universe wash over you. There is something deeply comforting in that, if you allow yourself to feel it. The light does not rush. The galaxy does not hurry. Time, at this scale, becomes something more like a texture than a sequence, something you rest inside rather than move through. And you're resting inside it now, carried along in the great slow turning, 30,000 light years from the center, spiraling gently outward with all the rest of the Orion arm. Moving, and yet still, the way a leaf can be entirely at rest, while the river that holds it flows and flows without ceasing. And the Milky Way itself is not alone. Of course, it is not alone. Nothing in this universe is truly alone, though the distances between things can make aloneness feel like the only possible truth. Our galaxy moves through a larger neighborhood, a local group of galaxies bound together by the soft, invisible thread of gravity, a small gathering of perhaps 50 or 60 galaxies of varying sizes, including our great spiral neighbor Andromeda, that other island universe full of its own hundreds of billions of suns, drifting toward us even now with its own patient and inevitable momentum. And this local group is itself nested within something larger still, a broad and luminous structure called the Virgo supercluster, a vast congregation of galaxies and galaxy clusters that stretches across hundreds of millions of light years of space, like a web of soap bubbles catching the light, delicate and intricate and overwhelmingly large. But even the Virgo supercluster, with all its multitudes, is merely one tendril, one branch, one soft filament within something larger still. We belong to Laniakea. The name means immeasurable heaven in the Hawaiian language, and it was given by astronomers who mapped the flows of galaxies across vast distances and discovered that an enormous number of them, some 100,000 galaxies in total, are all moving together, all being drawn gently toward a gravitational concentration that astronomers call the Great Attractor, all belonging to a single enormous supercluster that contains the mass of 100 million billion suns. Laniakea, immeasurable heaven, and we are inside it. One small pale blue world orbiting one ordinary yellow star on the edge of one spiral arm of one galaxy among those 100,000. All of us drifting together through something so large that the word large no longer quite does the work we need it to do. And beyond even Laniakea, the universe continues, the observable universe. That sphere of space whose light has had time enough to reach us in the 13.5 billion years since everything began, contains an estimated 2 trillion galaxies. 2 trillion, a number that the mind accepts grammatically, but cannot truly picture the way we accept the word ocean without ever quite holding all that water in imagination at once. 2 trillion island universes, each one containing hundreds of billions of stars, each one turning in its own patient way. Each one a world of staggering complexity and beauty that no human eye will ever see up close, that no human name will ever reach. And among all of them, scattered across all of that almost incomprehensible breadth and depth of existence, we know of exactly one place where life arose. One galaxy, one small rocky world on the outer edge of one ordinary arm, circling one unremarkable star in the quiet galactic suburbs, and from that world, creatures with eyes and hearts and the strange bright gift of wonder looked up into the dark and began to ask questions. The Milky Way is the only galaxy we know with certainty to harbor life. This is either the most ordinary thing in the universe, if life turns out to be everywhere, and we simply haven't yet heard its voice, or it is the most extraordinary thing we can imagine. A singular flowering of awareness in a cosmos that might otherwise have turned forever in beautiful and unconscious silence. Perhaps both things are true at once. Perhaps the rarity and the ordinariness are not opposites, but two ways of saying the same astonishing thing. The way a single wildflower growing through a crack in stone is both utterly common and quietly miraculous. What does it mean to belong to a galaxy? Not to study it from a safe analytical distance, but to belong to it the way you belong to a family, to a landscape, to the particular quality of light on a particular kind of afternoon that you would recognize anywhere as home. The stars of the Milky Way are not an abstraction. They are the furnaces in which every atom of your body was forged. The carbon in your cells, the oxygen in your breath, the iron that carries oxygen through your blood, all of it was made inside stars that lived and died long before our sun existed. Stars that burned brightly somewhere in this same galaxy and then scattered their gifts across the dark when their time was done. You are made of the Milky Way. You are the Milky Way, briefly and beautifully folded into a form that can look up at itself and feel something that might be called wonder or love, or the particular quiet that comes when something deeply true is recognized. There are nights, clear and still, when the galaxy seems close enough to touch, when the stars are so dense and bright that the sky looks less like emptiness and more like a ceiling dusted with ancient light, and you feel, if you're very quiet, something like the presence of all those suns above you, all of them burning and orbiting and turning in their great slow ways, indifferent and generous at once. On those nights, the distance does not feel like absence. It feels like depth, the way a deep pool of water feels full rather than empty, the way silence in a room can feel inhabited rather than vacant. You are not small beneath that sky. You are the point where all that vastness has learned to feel itself. You are the place where the galaxy pauses and notices that it exists. Every story ever told by a human being was told beneath these stars. Every dream ever dreamed, every grief ever carried through a sleepless night, every moment of laughter so pure it became its own small eternity, all of it happened here, inside this galaxy, under the turning light of this ancient river of suns. The cave painters and the constellation namers and the astronomers pressing their eyes to cold telescope lenses on cold hilltops. The children who fell asleep in summer fields and saw the stars through half-closed eyes. The sailors and the shepherds and the wanderers who used the sky as a map and a companion and a comfort. All of them yours, all of them ours. All of them held in the same soft galactic hands. The Milky Way does not know we are here. Gravity has no preference, and starlight carries no intention. And yet there is something that functions like tenderness in the way this galaxy holds us, in the way its arms curve gently around the quiet space where our world turns, in the way its ancient light falls on sleeping faces night after night without ceasing, never asking anything in return. We are held without being known, which is perhaps one of the deepest forms of grace, to be carried safely inside something so vast it cannot see you, and to feel in that carrying not loneliness but peace. Somewhere above you now, whether clouds hide it or the glow of a city softens it into invisibility, the Milky Way is arching across the sky. Its stars are burning, its center is pulling, its arms are turning in their long, slow spiral, completing one revolution in approximately 230 million years, moving with a patience so profound it makes even geology feel hurried. And you are part of that turning. You are being carried, gently and without fuss, through the quiet dark, through the great and ancient and incomprehensible beauty of a universe that somehow, for reasons no one fully understands, made room inside itself for creatures who could lie still at the end of a long day and feel the stars above them and breathe slowly and let themselves be small and held and wonderfully, completely home. The galaxy turns above you now, as it has always turned, as it turned above the very first night that any living thing on this world ever spent beneath an open sky. And somewhere in all that turning, in all that patient, ancient light, there is something that feels very much like the universe, quietly, softly, saying your name. And so our gentle drift through the Milky Way slowly comes to rest, like starlight settling over quiet hills. You have traveled 200,000 light years tonight without ever leaving your pillow. When you are ready, the next chapter waits softly for you. For now, let the galaxy hum its ancient lullaby around you. Sleep well, dear wanderer. The stars will keep watch while you dream.